Hello again, everybody. Continuing a tutorial from Toyota RAV4 and similar. As you see, like I said in my previous video, I was asked about this, where to get this, and like I said, I bought it years ago in an auto parts store, and I don't recall where it is, but I looked online, I couldn't find anything similar to it. Maybe there is something similar, a different company makes it, but nevertheless, that's why I didn't put any link or where it's available. But for the money that I spent on it, it's sure worth it. About $60, $70. It does a lot of functions, as you've seen that I had in other videos. Now, getting to this. Can't turn over the engine. No crank. Is it an electrical problem? Is it a mechanical problem? When we deal with schematics, for Toyota, it's called ECMs. Engine control module for this type and model. It might be called something else for a different make or model. However, for this one, this is ECM. This is the brain of the gang. This is the microprocessor. This controls everything. Now, what do I focus on when I look at a schematic? I have so many components over here. What do I focus on? Well, I'm focusing on a fuel pump. My first thing is over here is, here's a fuel pump right here. A motor. I'm focusing on this. I'm focusing on this. Whenever you see modules, that is a main component. I don't care if it's a TCM, a LCM for Ford, lighting control module, ECU, PCM, General Motors, they call it powertrain control modules, PCMs. That is a main component, and I focus on that. I focus on fuel injectors. I'm not focusing on sensors, because sense has nothing to do now with the problem of not starting the car. Focusing on the relays, but in that order. ECM first, and the fuel pump. How does it get to 12 volts? Fuel pump needs 12 volts. First thing you do, you measure fuel pressure. You need fuel pressure to build up, right? So let's say if you measure 40 psi, or similar to that, depending on the measurements according to the manual, and you always look up at the spec sheet how much you should measure. So I say, okay, everything is working correctly to the fuel pump. It must be a different problem. That means that 12 volts is coming to the motor to turn it on, because I have fuel pressure. Maybe it's a spark problem, but let's say I don't get fuel pressure, right? So I measure it, I go to the Schrader valve, and I go to the on the rail, the fuel rail. I attach the fuel pressure gauge. I don't read anything. Mechanical problem or electrical problem? Let's see how the electrical would work. In the run position, already you build up pressure. How do I know? Look at this. IG2 is similar to a run position. S2 is a start position. This is the ignition switch. This is accessories. Or your radio, whatever. Ignition, already I'm building up pressure, and I'm getting 12 volts to the fuel injectors already. And I'm getting 12 volts already to the fuel pump. To activate it, to the motor, to already build up pressure through the fuel line. How do I know this? Let's look into it. And this is a difficult diagram. Toyota is always difficult. But forever, anyway, first of all, an ECM needs 12 volts. We know that, right? So, I'm going to go over here and say, okay, I have fuel injectors here. I have a fuel pump. I'm going to start over here and backtrack. There is no rule that says you always start from the battery going this way. There is no rule like that. You always start at the component that you think is the faulty component when you're troubleshooting or analyzing something. In this case, the fuel pump. Start from that component and work your way back this way. You can go this way also in the schematic and say, okay, this way, but there's too many fuses. That will really help. That will not really help my cause. But I do focus on something that I know might be the problem or a main issue, and that's the fuel pump. Relays also I focus on. This, like I said, definitely I focus on. This I focus on. Main components. Right? Now, I come over here and I say, okay, one is ground, this side is ground. 12 volts. I need 12 volts at a fuel pump. Where do I get the 12 volts? Or where do I get current flowing? I come back up here. Pin 5, pin 3. I look at it and I say circuit opening relay. Fine. Come back up here. Right? Now, we know for this to be closed, this has to be activated. But for right now, for all purposes right now, we're going to go in the same backward trend of going back. So we're going to go back here. Remember? Wherever the current came here, came up here, pin 5, pin 3. This is closed. Come over here. We come over here. We come over here. Pin 5, pin 3. And what is this? Electronic fuel injection main relay. This is the main relay. We're going to come over here. This brings us back to, now we have two paths. Let's follow this path, even though I didn't color it in, highlight it in, whatever. Let's see where that brings us. Right away, I come over here, and I look at it and I say, again, these are the sensors. Not interested to me. The current will not come, or the 12 volts will not come from there. I'm looking for a power source or a fuse or a relay to give me 12 volts, not sensors. So this would be the wrong path to take, even though the current does flow here also. It's a common bus line. But it's not of the interest to me right now, because I'm focusing on where does the 12 volts come to this fuel pump. So again, I come over here, I have two paths. Going up here, through this, going up here. Going up here is of no interest to me. I come back the other way, the other path. As we said, EFI main relay, pin 5, pin 3, and this is closed, right? And we'll go over it. Now we come over here. Battery for the ECM. So right away I think to myself, okay, battery that means 12 volts. So you know what? I must be going the right direction. I must be leaning back to the battery or the power source. So this is the right path to take. I come back up here, no connection here. Come back up here, come back up here, come back. Okay, now a fuse. Now I'm getting somewhere. If there's a fuse, there must be this 12 volts somewhere, right? Sure enough, EFI. This is the fuse for EFI. And then obviously it's coming through a fusible link, 80 amps, and the battery. So this is the way I backtracked. Started here, even though we need something to activate this, but for right now, we assume that this is closed. I come over here. What do we say? I take a quick glance what the components are over here, and I say, sensors, nothing to do with my problem right now. Right now, I can't even crank an engine. Come over here, and say, okay, 12 volts here, I'm on the right track. Go back up here. I back probe. This pin of 17, 16, and I'm on the right track. So right now, we're on the right track. We know how we're getting 12 volts to the fuel pump. Okay? No pressure, nothing, no fuel pressure. Why? Because might be electrically there's a problem. Now, we assumed that this was closed, right? When we went this path. But in order for this to happen, we need current to flow in this one, current to flow in this one. How does that happen now? So, where do I start? Again, we did this path, the blue path. That's why I made separate colors. Blue over here. We're gonna concentrate on the orange ones. The orange ones over here. Let me get this probe. Okay? This is easier. Now, somehow we have to activate this first part of the circuit to close this part of the circuit. Therefore, I'm going to go over here and say, okay, we need a B plus on one side and a ground on the other side. And a computer can give us a ground. It could be our friend and give us a ground. We don't know what's in here. We don't care what's in here. That's not of our interest. All I know is I need a complete path. So probably I'm getting a ground through somewhere through this to energize this. So therefore, it might be a pulse, it might be a ground, whatever. Coming from here, whatever. But one side has to be B plus and one side has to be the ground. Can this side be the B plus? Well, I don't think so. It doesn't look like it. If I'm not sure, what do? I back probe again. I go back up. Again, 2 paths to take. Can B plus come here? No. Can this be the B plus coming through here? No. I go through this path and I say that goes to ground. That's not the path. That's not the correct path. Let me take this path. So far, I hope you're with me. Again, I'm looking for 12 volts on one side and a ground for the other side. We assume that the ground is being given through this. That makes sense. That means the other side is 12 volts. Can the 12 volts come from here? Again, one side going here, the other side of this relay coming here to ground. That's not the right path. What do we see here? A fuse. A fuse means 12 volts or current coming from a main power source. Now we come back up here again. 2 paths again. And what do we have here? A common bus line for fuel injectors. Can the 12 volts come from here? Nope. I take a quick glance and I look what's components are around this area. I see fuel injectors and I see a ECM. Can the 12 volts come from the ECM, from the fuel injectors? No. 12 volts must be going to it. At 12 volts must be going to these fuel injectors. And how many cylinders? 1, 2, 3, 4. 4 fuel injectors, 4 cylinders. So therefore, let's go back up here then. We're left with this path coming over here. Remember, this switch has to be in the run position. Over here in the start position, there is no connection. It has to be in the run position, or IG2 as they call it. Going through here, back probing here, and here we go again. Here's a fuse, 20 amps. Again, right here, through the fusible link. The same fusible link that we got the fuel pump running. So, as you can see, now, if you follow this one more time, go up here. Now we can start. We back probed and we came to here. Now I could go forward in the schematic. Now that I know the path of the current. Remember, current flows. Voltage does not flow. You can have voltage at your outlet, 120 volts AC, RMS. Doesn't mean you have current, unless you put a load. That's why I always deal with current. In the starter, if there's a wire, I could put a meter like this to attach it. That tells me how much current is flowing. It's a great troubleshoot aid. Now, like I said, since I know it's going over here, now I could go forward again in this direction instead of going back probing. So I can go here, current flows here through the switch that's closed in the orange, back over here, and yes, it goes to the fuel injectors. Once it's in the run position, the fuel injectors also get 12 volts. Go through this switch, right? There's 2 paths, one here. It splits up the current. Go over here. Now what happens? Now current flows, splits up, goes into this, activating this one. Current goes in here, activating this one. And where does this go? To this IC. So therefore, the current came from here to ground. And the other one, this is given a ground. So you see, you need a ground. Here's the ground through a junction connector, like a jumper. This one, we have a physical ground. The radiator right on the radiator. But this one, the computer gives it a ground. See? So therefore, when we come over here, this current flows here. This current flows here. Now, current can flow, and watch the current flow. As soon as these are energized by current coming in this direction, through the ECM giving us a ground, and through the physical ground of this one, current can now flow in the blue. Follow the blue through this, the main relay, through this, and through this, and through this. Only Toyota, 2 relays to get to a fuel pump. Only Toyota. So therefore, you don't measure fuel pressure. Why? Because it's an electrical problem. This is not being turned on. Why is this not being turned on? Let's say I come over here, I should measure 12 volts. How much should I measure over here? 12 volts. Look, all this is 12 volts. 12 volts. Right? Now, 12 volts over here. 12 volts. We're in the run position. 12 volts over here. This is 0. Over here, 12 volts. 12 volts. Now, let's say pump is not being activated. I don't hear the relays clicking, or I put the gauge. I don't hear fuel pressure being activated or increased. Now, what do? Where's the first point that I go to troubleshoot? Where's the first point that I go to? Now, what I do is, usually I see that this is a common fusible link. It feeds these 2 relays, and it feeds the other part of the relays and this. It's possible that a fusible link opened up. It's possible. Of course it's possible. Possible that the fuse is also opened up. Possible that this fuse opened up. Possible that there's something wrong with this. If I measure 12 volts here and I measure 0 volts over here, that means there's an open over here. This is not making contact. Or it could be in a short from here to ground. If there would be a short from here to ground, you'll blow the fuse right away. So it's like jumping the battery. The battery. So therefore, I come over here. The first place that I would measure, you don't want to go to the fuel tank to measure fuel pump. That's very difficult to do. You try to find somewhere an access point that you can measure somewhere. Right? So therefore, I would go to this fuse. This fuse right here. Look for this fuse. Why? Why wouldn't I go to these fuses? Go measure this fuse, and this fuse. And why? Why would I go to this point over here? Because this is like a common place. If I go to these relays, like I said before, I look for easy access points. The person working on the car, or my viewers, are probably people who are in the garage, in the backyard, and they have a problem, or they're in the middle of the street. If they're in the middle of the street, they're not going to take out a voltmeter and measure 12 volts. So then they're not in a repair shop working like Eric, the car guy. They're not in a repair shop where they have expensive equipment. They can only do this probably in their backyard or something to that similar. However, if you do have a voltmeter and you need a voltmeter, that's the most least of the test equipment. I'm going to come right here and measure 12 volts. If I measure 12 volts, guess what that tells me? That tells me that this is good. That tells me this is good. That tells me the ignition switch is good. That tells me that this is good. At least that much. Why wouldn't I put my probe right here and measure 12 volts? Well, because like I said, in order to measure something in circuit, a relay in circuit, you can't get to the pins. You have to have a relay inserter, or like I said, a relay box. What can I do? I can jump the points. I can jump these points to see if this is activated. Jump this to this. But not only do I have to jump this to this, guess what? Toyota makes it difficult. I have to jump this to this. Therefore, if I think there's a problem in the fuel pump or something like that, I measure 12 volts over here. Fine. Now what I'm going to do is I'm going to take 2 jumper wires, one from here to here, and another one from here to here. If I only use 1 jumper wire, this is still open, maybe, not activated. So therefore, I want to make sure I put here, I close this circuit, for sure. I know there's a path. If the fuel pump comes on when I jump them, that means there's something wrong with these relays. But the 12 volts tells us that this is good till here. That means it's an electrical problem. If I measure 0 volts over here, but I measure 0 volts over here, guess what? I'm going to go over here, go to this fuse. If I measure 0 volts over here, and I measure 0 volts over here, but I measure 12 volts over here, that means this opened up. So therefore, the fuel injectors also in the run position are activated. They get 12 volts over here, and they get like grounds, or they get pulsed on and off to open them and to close them when much fuel is needed to go into the cylinders. And all this depends on how much and how long they are. It's called pulse width modulation. Depends on all the sensor inputs, telling it how much fuel and oxygen sensors, how much oxygen, how much air is needed, how much fuel is needed, how much spark at the right timing. All this is the brains of this. So it opens and closes it, or pulses it, according to when it needs it, according to the air-fuel ratio, to do fuel trims, it's called. Therefore, I hope this was helpful. This is a difficult schematic, but thanks for the comments, thanks for everything, and please subscribe to my other channel, Automotive Electronic Schematics by Joseph, and the other one, Joe Electronic Schematics for Auto. Thanks for watching.